Okay, now we're going to see the rescue craft in action. The demonstrator is a very interesting unit. It has two fully reversible propellers that create thrust and the asymmetric conditions. And it has the built-in hoist that brings it up and down, and it will adjust for when the helicopter's drift is ups and down. So also it has incorporated a gyro, piezoelectric gyro that keeps it stable when the inputs are not created, and the feedback that sends to the wall and that gives it the signal to the hoist to which way to go for the self-compensation. So I'm going to put it in motion here, and we're going to see what we can do. Okay, now we inserted the battery and the whole system becomes active. Grab my remote control, which has been highly modified. And we're going to activate the winch. It's going to go up until we pick it up by itself. And we're going to start playing. So we have full yaw control. One way. The other one. And then we're going to make the hypothetical case of having a target on the window. So this is our rescue people. I'm going to put them here. So hypothetically this will be flown by helicopter, and we're going to get to them on a flat side. Once it's attached to the wall, the air pressure will keep it in the wire, regardless of the helicopter going up or down. As you can see, can you take the winch, move it up and down?
Yeah.
Once this rescue is performed, we back up the power. Bring it out of the wall. The helicopter will fly it too. Safety. Little glitches on the radio control due to the computer, so. Okay, we're going to do another test. We put a new battery now. We'll see what we can do. Have a different position here, so we'll bring it up. Okay, now that we have it attached to the wall like we want it, we can see how the outer winch works. If the helicopter goes up, let's say like that, it will self-compensate. Try to give the winch up really close. Give me a really up close. There you go. And when the helicopter lets loose, it will keep the reference on the wall level and adjusting up or down as required. So that will ease the pilot extremely to keep it level, flush, attached to the wall. Once the rescue has been performed, we're going to reduce the power and bring it back out. The helicopter will fly into safety. We can repeat the operations many times. Okay, another design of vertical research is the new reactive non-kinetic wire cutter. We know the wire cutters on helicopters rely on the kinetic energy that the helicopter is coming in order to cut the wire, provided this one is taut, supported by rigid supports, and a lot of luck. So, vertical research came with this new idea. This is my idea, barcella's design, of using an explosive charge that does the job. Okay, we have to utilize a clever design in order for that to happen. And this is the embodiment of our best prototypes today. The idea is to have a test bed that we can check it at high speeds and low speeds of cable entry into the cutting zone. Unfortunately, this device that will do the 100 mile an hour is not quite finished. Omit this one for now. Just swing it with my hand into the groove. And that will probably be a, 20 or 30 mile an hour entry speed. So, and that is when the real problems occurs. We know the helicopters that fly into wires low, they get entangled and they cannot get rid of it. So, the rest, we all understand how this works. So let's see how this works. These protective glasses, and I'm going to use this glove to avoid getting injured in my hand. Okay, ready? You got it close? Try to hit it. Here we go. As we can see, explosive charge detonated fully and cut the wire. I don't know where the other piece blew up, but I will get it here in a second for you. Oh, here it is. Okay, here's the other piece. See, we have this, I put tape on the ends, and we can see how clearly the cable has been cut. This is a considerable cable. If I open the strands, this is a stainless steel that it has 1, 2, can't see with this very well. Okay, it has 1. Get it over here so with a good light. 1, 2, 3, 4, 5, 6, 7. I guess all wires are pretty much braided into uneven numbers. And each strand is, or semi-strand, is comprised of how many filaments? Let's try to open up so we see what kind of cable we're dealing here with. I'd see at least 1, 2, 3, 4. There is 7. Well, 10. It's about 15 filaments each 7. So make the math. Cutting.